In this lesson, we will delve into the design of angle plate lathe fixtures. Angle plate fixtures play a unique and important role in machine tool processing, helping us to complete lathe machining tasks with greater precision and efficiency. We will thoroughly study the design principles and the key points of angle plate fixtures, and also explore their application value in engineering through practical case studies. It is hoped that through this lesson, everyone will grasp the core knowledge and methods of designing angle plate fixtures. Characteristics of angle plate lathe fixtures. Angle plate lathe fixtures are a common and important type of lathe fixture. Their structural characteristic typically includes a main body shaped like an angle plate. When the rotational axis of the part being machined is not perpendicular to the positioning support surface, and the positioning support surface of the fixture is not parallel to the mounting plane, the two surfaces form a certain angle, thus creating an angle plate form. These fixtures are often used for machining intersecting surfaces of components such as housings and brackets. The fixture consists of a base part and an adjustable part. The base part is composed of the fixture body, transition plate, fixture table, fixed support, and slide guide. The adjustable part includes counterweights, pressure plates, movable supports, and the positioning pins. The workpiece is positioned using two surfaces and a pin as the reference, and is secured with pressure plates, swinging V-blocks, and screws. Using an angle plate fixture allows the workpiece to be accurately positioned at the required angle and location, thereby ensuring machining precision. Design principles of angle plate fixtures. The design of angle plate fixtures is based on the machining requirements of the workpiece and the operational characteristics of the lathe. The core principle is to maintain a stable position and orientation of the workpiece during machining through a rational positioning and clamping mechanism. Positioning principle. Positioning is crucial to ensure that the workpiece occupies the correct position within the fixture. Common positioning methods include planar positioning and cylindrical surface positioning. For example, for a workpiece with both a plane and a cylindrical surface, we can use the plane and the V-block on the angle plate for positioning. Planar positioning can restrict the workpiece degrees of freedom within the plane, while the V-block can position the cylindrical surface, limiting the workpiece radial movement and the rotational degrees of freedom. According to the 6-point positioning principle, rationally arranging the positioning elements can completely restrict the workpiece's 6 degrees of freedom, achieving accurate positioning. Clamping principle. Clamping ensures that the workpiece does not shift under machining forces after being positioned. The magnitude, direction, and point of application of the clamping force need to be designed rationally. The magnitude of the clamping force should be determined based on factors such as the machining force, material, and the shape of the workpiece. Generally, the clamping force should be large enough to prevent the workpiece from moving, but not so large as to damage the workpiece. The direction of the clamping force should be directed towards the main positioning surface to ensure positioning accuracy. For example, when using bolts for clamping, the tightening direction of the bolts should be perpendicular to the positioning plane. Key points in the design of angle plate fixture structural design. The structural design of angle plate fixtures must take into account the shape, size, and the machining process of the workpiece. The main structure of the fixture should have sufficient strength and rigidity to withstand the cutting and clamping forces during the machining process. At the same time, the structure should be as simple as possible to facilitate manufacturing and operation. For example, when designing the shape of the angle plate, the angle and the size should be determined based on the inclination angle and size of the workpiece, allowing the workpiece to be easily mounted on the angle plate. Selection of positioning elements. The precision of the positioning elements directly affects the positioning accuracy of the workpiece. Suitable positioning elements should be selected based on the shape of the workpiece's positioning surface and the precision requirements. For planar positioning, support plates or support pins can be chosen. For cylindrical surface positioning, V-blocks or cylindrical pins can be used. The material of the positioning elements should have sufficient hardness and wear resistance to ensure their service life. Design of clamping mechanism. The design of the clamping mechanism should ensure reliable clamping and ease of operation. Common clamping mechanisms include screw clamping mechanisms and eccentric clamping mechanisms. Screw clamping mechanisms offer high clamping force and good self-locking performance, but are relatively slow to operate. Eccentric clamping mechanisms are easy to operate and provide fast clamping speed, but the clamping force is relatively smaller. The appropriate clamping mechanism should be selected based on the specific situation during the design process. Considerations for the design of angle plate fixtures. When designing angle plate fixtures, the following points should also be noted. Consider the working space of the lathe. The size and the shape of the fixture should be compatible with the working space of the lathe to avoid interference with other parts of the lathe during machining. Facilitate loading and unloading of workpieces. The design of the fixture should make it easy to load and unload workpieces, thereby improving production efficiency. For example, quick release, positioning, and clamping methods can be employed. Ensure the versatility of the fixture. While meeting the specific machining requirements of a workpiece, the fixture should be as versatile as possible to allow for the machining of various similar workpieces, thereby reducing production costs. Case study. Angle plate fixture designed by Zhongjie Friendship Factory for a maglev track beam machining special machine. The angle plate fixture designed by Zhongjie Friendship Factory for the maglev track beam machining special machine fully illustrates the engineering value of a structure serving. Strategy. The machining precision requirements for maglev track beams are extremely high, as the accuracy of their shape and dimensions directly affects the operational safety and stability of maglev trains. The angle plate fixture by Zhongjie Friendship Factory was meticulously designed to address the unique shape and machining requirements of the maglev track beam. Precise positioning. Through the use of special positioning elements and methods, the maglev track beam is accurately positioned at the machining location, ensuring the dimensional and the positional accuracy of all parts of the track beam. For example, by combining high-precision planar positioning with cylindrical surface positioning, the track beam is prevented from shifting or rotating during the machining process. Efficient clamping. An efficient clamping mechanism was designed to quickly and reliably secure the track beam, thereby improving machining efficiency. At the same time, the distribution of the clamping force is reasonable, preventing damage to the track beam and ensuring the surface quality of the beam. Adaptation to strategic needs. The design of this angle plate fixture not only meets the machining requirements of the maglev track beam, but also reflects the engineering value of a structure serving strategy. It provides strong technical support for the development of maglev transportation and promotes the advancement of China's high-end equipment manufacturing industry. In this lesson, we conducted an in-depth study centered around Project 3 design and balancing of angle plate lathe fixtures. We began by understanding an overview of angle plate fixtures, clarifying their role and applicability in lathe machining. Next, we learned about the design principles of angle plate fixtures, including the principles of positioning and clamping, which are fundamental to ensuring the accurate machining of workpieces. We then focused on the key points in the design of angle plate fixtures, such as structural design, the selection of positioning elements, and the design of clamping mechanisms. The design process also involved several calculations, such as the calculation of clamping force and positioning error, which help us optimize the fixture design. Finally, through the practical case of the angle plate fixture designed by Zhongjie Friendship Factory for the maglev track beam machining special machine, we deeply appreciated the significant application value of angle plate fixtures in engineering and the meaning of a structure serving strategy. I hope that through this lesson, everyone can grasp the core knowledge and methods of angle plate fixture design, laying a solid foundation for future work in machine tool fixture design.